All right, so with this figure here, A, B, C, D, E, does the figure have at least one Euler path? Hint, we're going to use Euler's theorem again. And if so, use the trial and error to find an Euler path that starts at E and ends at D. And then number the edges of the graph to indicate the path. And then use the vertex letters just separated by commas to name the path. All right, so again, first things first, let's figure out the degree of each of these vertices. So we have 1, 2. So that has 2. Here we have 1, 2, 3, 4. So that's 4. Here we have 1, 2, 3. So that's a 3. Here we have 1, 2, 3. So that's 3. Here we have 1, 2, 3, 4. So that's a 4. Now, remember, if it has exactly two odd vertices, which we have 1, 2, then it's going to have at least one Euler path. So yes, it's going to have at least one Euler path. So by definition, using part one of Euler's theorem, we have two odd vertices and thus at least one Euler path. All right, so 2. Now we have to do trial and error. And we're going to start at E. So we're going to start at E and we're going to end at D, which is good because remember, it has to start at one of the odd and end at the other odd. All right, so this is one of those things, trial and error. So let's maybe go up. I don't know. Let's go up here. So this is going to be 1. And then from there, maybe let's come down here. So this will be a 2. And then we'll come over here for 3. And again, this is one of the things you're just going to have to keep trying until you get it to work out, because sometimes you'll try it one way and it won't work, and try another way and it does work. So there's 3. Now we're back to here. So now we can't go up, so we have to go over here. So 4 kind of comes on this diagonal. And we know that we have to come down here on the last one. So let's go across here. So that will be 5, and then 6, and then 7, and then 8. So now we have all the different edges done. We started at E and we've ended at D. And so our path goes E, and then we went up to C, then we went down to D, then we went over to E again, then we went up to B, then we went over to C, then we went to A, then to B, and then we went down to D. So that is going to be our Euler path. And again, we just went up, over, across, up here, over here, up here, down here, and then down again. So that was our path we followed. All right. So now with this one, does the figure have at least one Euler circuit? So guess what we have to do again? We have to go and see how many vertices are odd or even. So here we have 1, 2, so that's even. 1, 2, that's even. Here we have 1, 2, 3, 4, so that's even. 1, 2, 1, 2, 3, 4, 1, 2, 1, 2, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4. So it looks like they're all even. So since it's all even, by the second part, so by part 2, then we have at least one Euler circuit. Okay. So because of part 2 of Euler's theorem, all of them are even, then we have at least one Euler circuit. Now, what's it say? We want to start and end at G. So we're going to start over here and we're going to end over here. And again, that really doesn't matter which way we go. So let's just kind of work our way down. So maybe let's go 1, and then we'll go 2, then 3. Now let's go around this, then we'll go 4, 5, 6, and we'll come across, we'll go 7, and then let's go 8, 9, and then let's go here. We can do two different ways. We can go up and down and over, or we can go up and over here. So maybe that's 10, and then 11, 12, and go across 13, and we come back down here 14. All right, so that's one possible. And again, like I said, we could have gone the opposite direction on our square here. We could have gone opposite direction on each of our triangles. So there's a lot of things we could do, but this is one possible circuit. So following that, it looks like we start at G, then we go to I, and then J, and then it looked like we went to H, then we went up to D, then we went down to F, down back to H, across to G again, then to E, then up to C, and then we went up to A after that, and then over to B, down to D, and then over to C, and then down to G. So that would be our circuit that would get us from G back to G. And guess what? It's also a path because we didn't cross anything twice. And so we have not only an Euler circuit, but we also have an Euler path. All right, let's pause there and come back for more.